Hello.
Hey there. Oh, microphone. There it is.
This is
Hello.
our first TDD stream this year.
Yeah, and it's dead, so we can actually skip it and go to the next one. So I just announced that we are that we are live now, and I wrote in the title "TDD is dead, long live self-testing code," and I hope I haven't ended my career now. So can you please explain why you have chose this as a hook? Why is TDD dead?
Nice setup, by the way. I love the
Thank you.
new streaming vibe.
Working on it.
Well, it sort of echoes my thoughts on like how we generally approach TDD. You know, people praise TDD, but TDD is never on anybody's number one priority. You know, like, on the list of priorities that your company should care about, TDD is never at the top. TDD is something that either is part of your identity or isn't, and it'll sort of bubble up as a sort of side quest to your engineering culture. But if you ask me, when is it really, the thing to follow? The answer is probably never. Now, that doesn't mean it's useless. It is very useful. But we're focused on the outcomes of the business, first and foremost. TDD in itself provides very limited strategic input. It is a tool to get things done.
I actually hope that people are focused on the output, because oftentimes it's not that much when it comes to technology.
Mm-hmm.
Yeah. So I know what you mean. I actually know no company so far which told me out of intrinsic motivation, hey, we're doing TDD, can we talking about that or something like that? I think that many companies who already use it, they are already far ahead regarding mindset and practices. So they already implemented probably several other practices, maybe some extreme programming stuff or other extreme programming stuff.
Mm-hmm.
And it is more like it is like I do TDD, not TDD, but I do advertising TDD in order to as a solution for many problems which are existing out there. But that's more the initial conversation, the point which makes the stone rolling, right? Okay, so we have some people already in the chat.
Yeah, we have a few people. Hello. The agenda for today is, let me open up the official agenda. So we got the verbatim stuff. So, oh, that's the wrong one. Let me bring it up. I want to talk to
Actually, TDD isn't dead, just to make it clear up front, right?
Well,
this was just a hook. It's LinkedIn. It's hook. We need hooks.
It's clickbait. Yeah, it is predominantly clickbait.
You got baited. Yeah, that's it.
I mean, in a way,
you need to accept
TDD didn't take off. We were sort of talking about TDD since 2000. Like when did the book come out? 2004, 2007.
I don't know the year.
I think 2004. So we're, TDD has been on the radar for 20 years and it never really took off. It's popular in our circles because we have a little bit of a TDD echo chamber on LinkedIn, because we talk so much about TDD that people who want to talk about TDD come to us, and then we talk about TDD because we're the people who like to talk about TDD. But it doesn't mean that it's the norm.
It's not. testing is actually
It's-
the norm, but if I ask companies on meetups,
Exactly.
so local meetups where
Exactly.
developers and companies are coming, they all talk about unit testing and end-to-end testing. They're not talking specifically about
Yeah.
a specific practice like
Mhm.
TDD is in that moment. And even though then they don't understand TDD, so there's this idea, but it's about testing. Okay, it's about testing, but it is a little bit more than just testing. So the idea behind that,
Yeah.
the is not known to the people. So why should you actually do that? And people say, I can't simply write my test before I actually implement because I don't know what to implement.
Well,
That's one most of the
that's a good question. You know, what is TDD about? Like, why do TDD? So, you know, if we're being very specific, TDD is not about testing. Testing is about testing. If you're doing testing, then TDD is something you can do in addition to testing. On top of it, right? Because obviously, if you're not doing testing, and I tell you, hey, did you try TDD? You know, it's like, have you, fallen from the moon or something? Like, Dennis, we don't test around here, right? So, I always come to the teams with this idea that, hey, like, you know, usually I have to talk teams out of, and this happened today as well on Substack. Had a great conversation with Ben, one of our regulars in the Substack Live. I'm refreshing my TDD booklet tomorrow, by the way. No nonsense TDD booklet, coming with a visual and a little bit of a content update tomorrow for my birthday. Tomorrow's my birthday. And usually people come to me and say, hey, TDD is really interesting. I think my team would benefit from this. I mean, it would feel very rewarding for everybody if my team did TDD. Just based on the feedback from the community about how, all of the people who have succeeded in adopting TDD, I want that in my team, right? Of course, like that makes perfect sense. But that is the tip of the iceberg. That's not the start of the journey, right? So the start of the journey of why TDD is we do TDD. So in comparison to testing, why TDD? In comparison to testing, we do TDD in order to refactor fearlessly. Let's study that again. We do TDD to refactor fearlessly. You can do this. You can do testing all you want. But we do testing first to eliminate as much of the implementation bias as possible. Right. So by doing the testing first, and one of the conditions for that is for you to be doing testing. By putting it in front, before the implementation on the timeline, we eliminate a lot of the implementation bias. You can still mess it up, but it gets a lot better. And the reason we do TDD, the primary reason we do TDD, is to refactor fearlessly. Now, why do we need to refactor? A common complaint is, well, why should I optimize for economic refactoring? Can't I just make it perfectly the first time? And why should I invest into TDD? Let's just do it. Let's just skip all that changing nonsense and let's do it right, like once. And that's possible. There are processes that do that. But they're very similar to TDD. I'm not saying don't do it. But if you decided to do that and you're using event sourcing with event modeling, then sure, you don't need TDD. Because you're already doing essentially functional programming with immutable data structures and a very, very easy to follow Gherkin syntax of given when then. That's basically doing TDD in Miro without writing the test down. I have no problem.
That is not like applicable to most of the other areas, like typical front-end development is not like that.
Oh yeah, it is. But it requires a different approach to state management.
No, what I mean is the way of testing it. What you just said. That's a little bit different. Okay. It's actually possible now to see Caloyan's image.
Yeah. There's no such thing as doing it perfectly the first time, if you ask me.
Yeah, that came to my mind as well. I never saw that actually happen. Hey, for small features maybe, yeah, but not for complex things.
But that's not even the point. The point isn't the point of TDD isn't that you're testing it and then you have like a proof that we can now say that there's no regressions, because the point of TDD is to see a failing test so that you know that your failing signals are correct, because you will rely on your failing signals to refactor, right? So if you write a test and it doesn't fail when you wrote it without the implementation, then you know that it's not reliable. So you can't rely on refactoring whatever it is covering, whatever lines of code it is providing coverage for. Those you can't refactor, right? So that's kind of the idea. And I've been playing around this new idea called touchpoint refactoring, where to highlight the difference between BDD and TDD. I mean, they are the same thing. BDD, TDD, ATDD, they're the same thing. That there's a little bit of nuance about how you write the tests. There's people ask me, Dennis, how can I write the tests that are not implementation specific if I'm implementing something? And it's a fair question. And the answer is you're using test helpers to sort of capture the permutations of testing, right? So you might have permutations of 100 tests that are testing like 3 classes or 3 systems that are using 5 classes or 3 classes. And then the mention of those classes is in the helpers, but the tests only, have like a domain specific language or Gherkin syntax for the testing. Krishna says the future isn't about writing tests
Can you
first.
pump up your chair a little bit?
Pump up my chair. I can pump up my bum a little bit and just sit higher. Yeah. The future isn't about writing tests first. It's about code that tests itself. Yeah, like that's the point of the stream, right? So the point isn't that you are mechanically following the TDD process. The point is that that when you are writing code, that code tests itself, ideally within the same iteration as you wrote it, so that you can refactor it in the next one. Great highlight. Thank you, Adrian. Awesome production. So the core intent behind TDD is that we need to refactor sooner than we can predict. And in order to make refactoring economical, the easiest way to do that is to have tests that aren't tied to the implementation. Because you can have tests, but if the tests are tied to the implementation, then I can't refactor, because whatever the tests are touching will make the tests if I refactor the touch points, right? That's why I call it touch point coverage. Touch point coverage is this idea of you take test coverage that the tests provide, code coverage that the tests provide, and then you subtract from it the symbols that the tests are mentioning, directly, right? So if you're using a test helper, like some kind of domain-specific language, usually strings, or some form of Fluent API that says an admin user, and then those are 2 functions that behind the scenes, I don't know, make API calls and create an admin user, right? So it's this idea that your fixture management, your setup, etc., your events that are going into the system prior to you calling the main method are hidden behind some facade. Those mentions directly in the test files, those you would subtract from test coverage, because they're not safe to refactor. When you refactor that, the tests break, right? So BDD is this extreme of you can refactor everything. You can refactor the highest facade level of the API, the highest boundary, the most public boundary. You can refactor your APIs. You can, because you're using the language of the business, and a B2B e-commerce business is going to be in B2B e-commerce for a very long time. And when McDonald's says Big Mac means something. It is very unlikely that in the context of McDonald's there comes a point where you say,
talking about food, please. I'm hungry. Thanks.
Like, it is very unlikely that in the context of McDonald's, sorry, Adrian, the word Big Mac, at some point somebody says, you know the word Big Mac? Oh, from now on we're using the word. It's like we like the SEO and keyword density on social media. So from now on we're gonna use the term Big Mac to mean some other burger. That's not gonna happen. Like that's silly, right? I mean, it could happen that your classes and your features, your server names, your server products might get a different code name, might get a different name, they might get refactored. But from the terminology of the business, that high-level business terminology is unlikely to change, which is why we then gravitate towards it to describe what the tests are doing, rather than class names, rather than function names, etc. That's then another level of indirection that you can then use to make your tests a little bit more, well, to reduce the touch points that your tests are, that your implementation is facing in the tests direct touch points. I'm still working on this.
I don't wanted to share this directly. I thought that StreamYard is first preparing that in stage, but it doesn't. It is instantly popping up. So
Yeah, go for it. Just zoom in a little bit, please.
The thing is, I just wanted to find out what actually self-testing is, because to be honest, I wasn't very much aware of this thing. And since TDD is dead now, so you need to rename your TDD February to self-testing February.
Nice.
Can you please explain a little bit more, because there is not much stuff out there which actually explain what the topic is about today.
Well, Adrian, keep up. We already explained it, right? So the idea is that the code is self-testing within the same iteration when it is implemented. Right? So the problem with writing tests after is that in between writing the implementation and the first generation of tests, there can be no refactoring. So if you need to refactor the code in order to test it, you have essentially created legacy code day one. Right? So the idea of self-testing code is that it is testable within the same iteration as it is created. Like that's, and then the artifact.
More precise. What is the difference between TDD and self-testing code then?
Well, TDD is a methodology of how to create self-testing code. TDD is one of the processes that reliably simply produce self-testing code. And you can think of self-testing code as code that to have facilities of having health checks for itself.
Okay, because that's what I was reading beforehand. It is more like treated like a sister, so a sibling to test-driven development, not really like it is like.
Adrian, this is a 10-year-old article. This is a 10-year-old article. The terminology Martin Fowler used here is a little bit archaic in today's sort of sense.
I saw that he was doing a new video with Dave Farley about that.
With Dave Farley in the engineering room, and now with Luca from refactoring, where he was sort of re-emphasizing this desert versus forest metaphor about, like how does your team identify? Are they fear-driven? Are they abundance-driven? Are they in a place where experimentation is welcome, or are they in a place where it's pressure, constant work, lots of stress, nobody's refactoring?
Good.
Most of my clients are coming from deserts, right? So most of my clients we're super busy. I had a conversation today with Ben, maybe a potential client, on Substack, about this idea that, we're super busy. We have a lot of bugs. We're a startup. And, we have a lot of things going on, not a lot of time. And as usual, people in the desert, I have to talk out of having a TDD workshop, because I'm not going to waste your time doing a TDD workshop if you're busy all the time, because you won't have time to apply it, right? So I'm just gonna, if we invest time into doing a TDD workshop, you will want the time back, right? Because why do you need to refactor? Why do you need self-testing code? Well, you need self-testing code because when new code that you just wrote, if it's self-testing, it can immediately be refactored. And when do you need to refactor? The timing points for new code. You don't refactor all the time. Everybody knows the scenario of, I want to rewrite this because I hate it. It's been here for 5 years. That's a touch point. That's contact. That is contact. And that is first contact with a new owner of a legacy system. Right? So code that was written.
You refactor often, isn't it?
Sorry?
So you actually refactor often in a in a better scenario, I would say. So my
Yeah, I would say
tendency
more
is to
frequently.
refactor
Yeah.
when I can.
Yeah.
So that's how I do it. So I remember that Dave Farley stated in his book. Basically, he I think he quoted it as well, but it was that high performing teams are actually refactoring 60% of their code base yearly or annually.
Yeah.
So you should have the confidence actually to do that. And so then I have understood the difference, or minor differences between those two approaches. That's okay, but so for the audience right now, okay, we need a restaurant metaphor. Please think about that.
We already did McDonald's, but
that doesn't count
Kaloyan
as a
wasn't
restaurant.
Kaloyan wasn't paying attention.
That's a fast food
You missed it.
burger
You missed
dispenser.
it.
But yeah, but yeah. Anyway, so in the audience, maybe Carlo, Krishna, do you actually use TDD or self-testing stuff or BDD or anything about that would be interesting to know from you guys. We have several people now in the audience in different places, so please tell us a little bit about how you actually do your testing, because every time I ask that, as I said, on meetups, on startups, or even conventions or something like that, people tend to say, yeah, we test, but not everything. And there are some people who say, oh, I have a test coverage of 100%. I'm doing it every time.
Yeah.
And most of the times when I hear that, the actual implementation is a little bit like, maybe you can delete all your tests because they're actually quite worthless. I wouldn't say that test coverage is something you should focus on, and that's especially in the TDD space not really relevant, because there are spaces you don't test anyway with TDD because they are too integrated, and you can basically focus better on what actually matters. And you will see that's one of the nice things when you practice TDD is it is a living thing, because you do that every time before you actually do the change or the addition, which makes it so integrated in your process.
It depends. Every time is like there will be a huge difference.
I have my test open every time when I develop the function itself.
Me too. But there's there's a common misconception. There's a huge difference when we say every time. There's a huge difference between 100% of the time and 99% of the time, right? So if I'm writing a config, I might not test cover the config.
This is what I meant. You don't do you don't do everything. So it's a little bit like but when I think of a component,
but I don't negotiate, right? Like I don't entertain this mental lingo of, oh, should I TDD this? Should I not TDD this? Oh, it's front end. Should I TDD this? Should I not TDD? No, I'm going to TDD everything. Everything that is meaningfully going to contribute code.
I don't, to be honest. I don't. No? So configurations of environments, I don't test them.
Not configurations, but like behavior code.
Yeah, that's what I meant by the important things and not everything. So, for example, if you let's stick a little bit with frontend, because we have covered that already so often in the practice thing on this channel.
And we have a Next.js stream coming up end of February with Nick Shoemaker. It's going to be a big one.
That will be an interesting one, yeah. But you have a lot of spaces where you actually, so TDD works really well in the space of unit test, component test, because you can align that very, very, very well.
And wider as well. I wouldn't say...
You can even do TDD with end-to-end tests if you like.
Smoke tests, acceptance tests. Yeah.
You can write the test before you actually implement that. And,
it works very well.
Yeah. It works, right? But there are some parts which are sometimes I really call it like not really worth testing, because they will work anyway. And there is a little bit like, for example, routings or something like that. It is, let's say, you can test those things, but oftentimes it makes more sense to actually write additional tests for specific things and not really testing in the context you are right now. So oftentimes you should simply focus on what you're doing right now, and that makes it way easier to refactor later on, because if several things or several tests test the same thing, you will get problems on some point. And if you're staying right now with component tests and unit tests, and then you should not interfere with other tests as well. I don't like that.
So when we're talking about test isolation, for example, you raise a great point. We don't want a huge overlap of coverage. right?
Yeah.
So we wouldn't want to have the system be fully unit tested, integration tested, and end-to-end tested, because that would create a huge overlap on the responsibility of the tests, which means that if one feature breaks, there would be 3 tests failing, and that's not really helpful to us. Like ideally there would be like a strict barrier between if behavior breaks, there's unit test failing. And when we wrote the end-to-end test, it doesn't make any assumptions about behavior, if that is possible.
It's plain expectation. So end to end
It's
is
just
like,
it's
is
just
that there
plain.
to the time?
Yeah, like did it load and was the response 200, and was it more than 0 bytes? That'll be like a reasonable smoke test that uses end-to-end tooling. Maybe there's a button and I can click it, and that's as far as I would go, and then the rest I would test in a different flow. But how to slice a test is a different problem. I don't want to talk too much about that today. We can do another stream about that. I want to come back to the idea of refactoring and why the test first idea is so different. So you said something very interesting a moment ago about when you ask people, what is their workflow? Who in the audience is doing TDD? How I like to phrase it is, let's assume you're not doing TDD. Whenever I ask this question, it's like 20%, 15-20% of the audience raises their hand. It's like, yeah, we're doing TDD. And a lot of them aren't, and they just don't know. Look, it's complicated. The point is
self-testing.
If you're not doing TDD, what's your process? That's what I'm interested in. Right? So if you're not doing TDD, is there a formal process? When do you write tests? At what phase do you run the tests? Right? Because TDD is really helpful because it formalizes when you have to write the test, when you have to run it, what are the conditions for a correct test, what are the conditions for correct coverage. You can simulate whether you're losing coverage on touch points, right? You can check, with my definition of touch point coverage, you can check, okay, did we go a little bit too far in the test? Do we need a helper? Do we need a domain specific language? Do we need to activate our domain experts and create a little like a little dictionary that we can all use together so that certain words mean certain things? If you're not doing this, then what's the process? Where is it written down? What do you call it? When does the test happen? Do you negotiate whether you test or not? Who decides what kind of test you're creating? When do you decide that? Is that part of your spec? When do you run the tests? Do you run all of your tests? Right? Like, does the developer run all the tests all the time? If not, when? Like, that's what worries me, right? Is that if you tell me we're not doing TDD, I'm like, okay, cool. So what are you doing? And it's usually, well, we write code and then we test it and then we hand it off to QA. I'm like, okay, but there's so many things undefined now. It's like, okay, but when do you run the tests? Like, what's the minimum guarantee for if I make a change? When do you run the tests? When do you run the tests for the change I just made? It's like, yeah, our CI/CD pipeline runs it, but that's really late. If we wait all the way to the CI/CD pipeline, that means that it's either already in some merge procedure or it's already in some review phase. Or if it was done by chunk-based development, you might not even see it running because you just assume that, yeah, like this is just Tuesday and it's running. So it begs the question of, if you're not doing TDD, who defined your process? Like, to what degree is it defined? And I find TDD to be a very simple to follow process that has a few steps, and it actually creates a process that has a lot more rules implicitly than TDD has steps. TDD has like 4 steps, right? Like, define the test plan, like 5 steps. Okay, define the test plan, write the test, implement it, refactor, and repeat. right? To go back to 1. Like I'm counting go back to 1. I'm counting the go to as a step as well, right? There's only 5 steps. And this 5-step methodology creates easy to predict rules about when the test is written, when the test is checked, when the test is being rewritten, when the test is being run, how the implementation is being done, how much of the implementation is done in between tests. This is super useful, right? So you come up, like, it's almost like the game of life, right? Like you have a few simple rules and you have this like emergent complexity of, like a few people follow these simple rules, and it just creates this rule set that is actually very rich, that allows, complex systems to collaborate in a way that aligns everybody's sort of workflow together. Like, I find it very fascinating. But going even further than that, you said this is about testing. I wouldn't say this is about testing. It's about development, right? Because it defines when in the development phase the tests get written and when they get run and when they get defined. That's super useful to have like an SOP for, okay, like here is when we define the test, here's when we define the test list, the one particular test, the order of the tests and the implementation, and then we run them and then we check for refactoring. Because now I have an expectation of, like I know, like I have it written down when I should be refactoring. If you're not doing TDD, when in your development process does refactoring happen? When do you receive feedback that you need to refactor?
That's very
do you receive feedback that you need to refactor before or after you write the tests?
I think that most companies actually, or tech teams, even engineers on the solo level, they don't really think about those questions. They simply don't do it in that manner. So sometimes they maybe do a test, sometimes not. And the nice thing is, so I was trying to follow you. So I was actually following you, but I can't really transfer that into my hands-on stuff or when I see others working, because it's so let's say it's a natural process. So TDD becomes very natural. You don't think too much about it. You naturally know when to write down a new iteration in a test or something like that, or a new integration test or whatever. You know that. So it's a little bit of, that's a complex thing. I need to do several test cases for that one, or for that one I need a little bit like that must be simple, like red or green or something like that.
Yeah, just following the zombies, like initial state. The first
very simple sometimes, but you need to do that. You said 5 steps. I don't even count steps. I wasn't aware of that. It's a little.
That's an example to just get the formal definition through, so that we don't so that we stay on point regarding.
I think when you do
TDD.
something like TDD, you don't have 100% thing. You don't have it 100% tested most of the time, because sometimes you get a feel for what you actually need to test and what not. And but in the end you will get so much feedback because you do that constantly, continuously, every day. You have so much feedback about what's actually working and what's not, especially in startups and companies which aren't like where nothing is so critical, let's say. It is extremely valuable to work that way, so you have a very good quality and stability while you can still move very fast forward, which is great. And when you don't do that, so
you're about to say it. Sorry,
so
go ahead.
When you don't do that, it's a little bit like you don't know where you are. It's a little bit like you don't follow another system, and when you have a system, it's too complicated, so you don't follow it again because it's too hard to follow. That is what I often see, that people sometimes simplify tests in order to get the system done. So it's more like you work for a system. That's a typical coverage thing. So I have 100% coverage, so my job is done, agency stuff of work, right? So there's in the contract this, you need to have at least that amount of code coverage.
Yeah, because it's a guarantee that they give in the contract, and then it's...
No.
Yeah, me neither. Yeah.
And then you take over, and the first thing you do is delete the tests.
Yeah.
That's what you do.
Because they're not useful. They're brittle. Anyway,
they're hindering
I want to touch on this idea of like development versus testing, because a lot of teams simply don't refactor. Right? So, and this might be controversial, but TDD is a complete waste of time if your team never refactors. Right? Like the whole point of TDD is we have tests, like our implementation is self-tested the moment it is written, so that we can refactor. And that is, economically speaking, that is an upfront investment, a very small, frequent, but consistent upfront investment. And if you know with a high degree of certainty that you consistently do not refactor, then this investment is it's you're never getting it back. Right? So I always say, TDD is useful to you. Well, no, actually, TDD is not your top priority generally. I first need to see evidence that you actually do refactor, or you show pain of needing to refactor something and you're afraid, and you're just and I shadow such a team and I see them procrastinating, and everybody's looking at the code and they're like, how do I break the least amount of stuff?
Don't touch it. I need to go
Yeah, don't
home
touch
and
it.
have
How do I break
problems
the
with
least amount
TDD.
of stuff? Like, that is good evidence, like evidence of refactoring, or just the sheer pain of having to change something in a complex legacy system. Now, the pain can be a manifestation of just recurring bugs. You have a bug, you fix it, it goes away, and suddenly it comes back a week later. You have a bug, you fix it, and suddenly in a similar area of that system, something else comes back, and you just keep. It's like nobody wants to touch it because nobody's really afraid to systematically say, you know what, this is a bit dated. Like, the architecture no longer serves us. The behaviors are all over the place. There's some duplication going on. There's some accidental coupling going on that shouldn't have been wired together. We need to refactor this, but you can't because you're afraid to touch it, right? So you're afraid to touch the implementation.
You avoid touching your system actually wherever you can, which means that it won't improve, which means it becomes worse over time, because every time you don't do that, right? You create, you lose more knowledge about the system because you don't gain
and
it.
trust. Yeah.
Exactly. So the people who initially worked on the system are very often not there anymore, maybe one or two people still. And when they then leave, no one is actually brave enough to make a change to the system, because
that's it.
It is the fear of making a change to a system is actually blocked, or it's also not blocked, it's caused by the lack of confidence to actually fix it when something goes wrong.
Yeah.
So the first part is you are not sure if it actually breaks something, and when something breaks, you're not sure what you do. And that's a little bit like, especially when many people merge their, in typical non-continuous delivery environments, where many people merge their changes to something, and then you would make a change in between and you can't simply roll back. You need to basically manually roll back your change again, but then they still ask you to make that fix and you don't know how, and you are back to zero, but you need to do something and you still don't know how. Right?
And that's a simple system. In a more complex, large system, like multiple millions of lines of code system that is very heavily reliant on, let's say, data dependencies, like structures of data, where all behavior paths aren't traversed all the time, every day. Maybe one behavior is traversed once a year by one client. In such an environment, in a complex system, you might not even know whether you broke something. You will only find out if the test was reliable and it was tested, it was good, but maybe it's just end-to-end test coverage and you don't know whether it was fully reliable, or it's not test covered and you will find out by the next time somebody uses that feature. Right? So not only is it, we broke something, how long is it gonna take? That's just the tip of the iceberg. What is the chance of you even being able to predict whether you broke something or not? And whether, knowing that, you would even dare touch it, whether you would even accept it on the backlog, or just say, hey, I'm not touching that, or hey, we need the entire team for this because I need help because I have no idea what's going on, and resist the urge to rewrite it without having full understanding. Right? So there's generally 4 types of contact points of code. Like, the worst contact point for refactoring is a new maintainer accepting untested code, right? So code that isn't self-testing, because that person is now essentially dealing with legacy code, and they are tempted to either refactor it, rewire it, rewrite it, whatever. And a mature, experienced developer will always be tempted and be aware of the temptation and try to resist it and find economical reasons to now have to sort of navigate this landscape, this part of the system, with safety gloves, right? And that's very complicated. That takes a lot of mental effort to say, oh, you know what? We have to be careful there. From now on, we have to be very careful there. But if I am touching it, I'm doing it at a very high level of quality. I'm making sure there's no more mistakes from now on. I'm taking over. I'm not propagating this fear into the next generation. That's touch point number one. That's the worst one. That's the latest one. Then there's the first three touch points, and I will describe them in the actual chronological order, right? So, and they align with continuous integration, continuous delivery, and continuous deployment, right? So you don't refactor all the time. You can refactor all the time if you want, if you're bored, because it's sort of an endless activity. You can do it anytime you want, but it's kind of pointless. Generally, you refactor with some change in mind, right? So I will go and refactor because I want to add a change, and I will refactor the system to more easily accept the change I'm about to make. So usually you don't refactor A to B, you refactor, you refactor A to B given future change C. It's like that implicit I want to build this feature is very important for the actual refactoring step, because it scopes you, it gives you time pressure, it gives you sort of an investment analysis of, well, the feature is going to be this big, I'm not going to refactor more than that, because otherwise I could just implement the feature the bad way, the hard way, and then see how I go about it, right? So refactoring isn't a continuous activity. Refactoring has spikes. Every time you add a new feature, every time you add new behavior, every time there's new code, the need for refactoring, the opportunity to refactoring happens every time your new code, and only the new code, makes contact with a new human being. So with continuous integration, that new contact is another developer. Like you write something, you refactor your code, but that's simple. When it touches another developer in pair programming or in code review, that's then when, hey, we missed something here, can we refactor? That's the first time you actually really need the tests. That's why self-testing is so valuable, is that it is already available to you. It's like, okay, you know what? Yeah, it works, but you're right, we should refactor this. Like I missed the mark on the design. This is too complicated. Or I misunderstood and I sort of, I generalized a little bit for future needs and I shouldn't have done that. Mm-hmm. Right? And if you have tests in, then you can go immediately spot the issue and fix it. Right? So that's integration. Contact point with the first human developer. Then there's continuous delivery, which is contact point with the first human product owner. Right? So somebody who is product oriented. That can be another product engineer, that can be a data scientist, that can be your tech lead, that can be an architect, that can be your CPO, your CTO. It can be somebody you're dogfooding your product to internally. That can be QA, right? But when you're doing continuous delivery, there's an immediate need for refactoring of, oh, no, you misunderstood the feature. Let's do it again. And then you'll change the behavior, you change the design, and at that point, there's an immediate need for refactoring. Right, so that's the contact point number 2, which is going from engineer to feedback from somebody, a product-oriented stakeholder.
Change instead of a refactoring. So
it depends. It depends, but
like, you don't change the idea behind it.
You refactor in order to make that change easier.
Okay, that's the vibe.
There's multiple steps involved. Yes, okay. You're right. There is multiple steps. I'm not implying that. I'm not implying that us being wrong about the feature that's refactoring. No, but we might want to refactor what's there in order to fix our misunderstanding. And then the third one is first contact with a human client, with a customer. Right, so with an actual end user in the actual production environment. Right, so that's the third feedback point. That's continuous deployment. Right, so now the point of these contact points is that they represent on the timeline areas of feedback, and particularly when it comes to like the technical details, bugs. That's when you discover the bugs. And when you discover the bugs, that's when you want to reintroduce and go back and iterate on the feature and change something. And that's just prior to that change, and possibly prior and after that change is when you will want to refactor. So that is the timeline. Plus, then 5 years later, the new owner, right? But we all know that one. But the TDD really focuses down on these first three, because we want the code to be self-testing before you hit those three milestones, so that the coverage already enables quick economical refactoring. I'm not saying it's going to be super easy and fast, but at least it's going to be economical to the alternative when you need it. And really the point to emphasize with this kind of refactoring is that let me just be very careful with the phrasing, is that the team needs to integrate while they are still focused on that feature. Right? So you will not be doing any kind of refactoring fearlessly and simply and economically if by the time the feedback has reached you, you're now busy with some other feature. That is the breaking point. Right? So first, what you need is continuous integration, and then doing TDD alongside that. If you're doing TDD and you're never doing continuous integration, yeah, sure, you wrote tests, but you didn't make contact with the next human being. You went working on something else. In such a scenario, you're also wasting your time with TDD, because by the time the feedback hits and the need for the opportunity for refactoring arises, you're now busy with something else and you can't respond to the opportunity. Even worse, if you never get back to it, you now need to put refactoring on, you need to talk to your Scrum Master to do refactoring, which is pointless, but it's about cadence. It's about the order of events in which the particular activities happen. Right? I want to build something, release it, and then respond to feedback. And if there's no immediate feedback, then I start working on my next thing, rather than stratifying and fragmenting this workflow such that I code, then I test, I skip a few things that I coded, and then somebody else releases at some point in time in the future, and then when the feedback hits, I now need to have like a road mapping meeting to determine when I'm refactoring and what, and at that point the battle is lost, because this is then no longer an economical, quick, immediate, simple, and continuous process. Now this is a disruption, not this is no longer a high-performing team then. Refactoring has become a disruption, and at that point you're in that fourth contact point of, yes, we've just created legacy code, and instead of dealing with it immediately, fearlessly, courageously, just boldly do the change we need so that we can fix the bug, we now need to plan it and put it on the calendar and and make time for that's going to be one of those refactoring sprints, and that's a waste of time. And if you do TDD and you don't do continuous delivery, or at least continuous integration, then you're also not benefiting from TDD. That would be sort of my Adrian, I just saw your message. Yeah, it's okay. We can wrap slowly.
One of the interesting things about that is that refactoring, first of all, is an extremely important topic, and it should be very natural in your flow. So when you see, okay, I need to implement something, and I see that actually I need to change the code in order to implement that in a more natural way, then I need to do that. It is a little bit like refactoring in general should not become a topic of its own. Never. It's when you are in front of and I see that very often. Unfortunately, it's the typical thing where people say, "Yeah, we haven't deleted many things, even if they were removed, because we don't know if we can remove that part of the code right now. If somebody needs that part still, or for documentation purposes." The point is that this is the reason why we have Git or something similar. That's the reason why we version actually, and you should be able to remove things. And
Yeah.
when you do TDD, that's one of the interesting part. Of course, you have a similar thing with testing, but with TDD you do it very naturally. You know
Yeah.
when you can delete things because you don't need to be there as the author of the original component to say you can do something or not because it is manifested in the test cases, right?
Yeah.
So if the test cases are defined and you delete something and everything is green and you know that your tests are actually valuable and they actually test things instead of being too shallow, then you have the confidence you actually need to do that. The only area where you can't be sure about if it breaks something or not is CSS. If you delete something there, you're screwed. Just joking.
I mean, but CSS is also a declarative language, so the rules of the game are slightly different.
No, it's just joking because so many people are afraid to delete anything from CSS.
Yeah.
It's a little bit like I
I
don't
mean,
know
but it's
why.
similar, you know.
It's
I mean, what you would need with CSS is tree shaking. You know, it's like remove unused CSS or like merge, you know, refactor CSS so that I can merge.
that's one of these points.
common.
So CSS, like what is unused CSS if you have traversing and cascading? It's
Yeah.
a little bit like very hard to tell when it's actually used or not, especially in older systems where you traverse a lot, because there were some systems where you needed to make changes with CSS to an existing system, so you can't put IDs in classes, but instead you were traversing to the tree through the tree, which was very adventurous, to be honest. Like 10
It's a different form of
traverses,
coupling. Yeah.
and you basically can't delete anything there because you simply can't see that what actually happens. And that's another totally.
It's a different topic. It's an interesting topic, but it's far too complex for us to practically unpack now in 5 minutes. Yeah, I just wanted to mention this idea that, you know, ultimately, whether you're doing TDD or not, and you know what metrics you're using alongside of its training or introduction or maintenance, is that the biggest shift happens when your team matures to the point where you say, we're not going to ship low quality anymore. Okay, we will define the bar for quality and we will not ship anything that's below that bar, right? So there will be certain things about our culture and quality process and security process that are non-negotiable. Everybody goes through them. Rather than it being this, yeah, maybe I'll write one, maybe not. If it's hard to test, I might skip it. Or I'll ask somebody in QA to end-to-end test cover. It's like, no, like there needs to be a process and it needs to be known before you start the work so that it becomes non-negotiable. And there is this maturation point where you just start doing these processes when nobody's watching, right? So nobody's measuring test coverage, nobody's breathing down your neck, and you're still writing tests, you're still making sure code can be refactored. You're writing DSLs
because it's intrinsically. So you're doing an intrinsically, let's say, you have an intrinsic focus on motivation, and not an outside focus on you need to do that, otherwise it doesn't.
Yes. So because what I see a lot is process reinforcement metrics, right? So people say, oh, I will do, you know, I want tests to be written, so I will introduce coverage as a metric, but then that is process reinforcement. The identity of the team is that they don't want to write tests, and which means they are a non-testing team. They are never testers. And now there is this process reinforcement metric that can be gamed, where the team is being reinforced with a stick into this behavior of, yes, you're a never testing team, and the KPI is punishing you.
Yeah, you write tests. You don't aim for quality. You write tests.
Yes.
So
to avoid
goal
punishment.
Is a different one.
Yes. You avoid tests you write the test to avoid punishment, right? It's that agency example you mentioned, right? So
it's 100% test coverage thing.
But the team but the identity of the team remains the same. They are never testers. They don't want to write tests. If nobody's watching, they won't write it. And that's the most important aspect. That's what needs to be worked on if you want to take this seriously, right? So if you're in such kind of environment and you ask me for a TDD workshop, I'm like, no, because you don't write tests, right? It's like it's really important. TDD is about you testing already, and then we decide to write them first so that we can refactor sooner. So that you can refactor on all 4 contact points with other humans, not just the last one when you want to rewrite the whole fucking system. Because it's just going to be really complex, and then we have these conversations about strangling Fig and continuous modernization, and it becomes like this whole system process. But the innermost loop is where the most value is. So you will always come back to the level of identity of the team. You will get more of what's already there, right? So you will get the level of quality that represents the identity of the team. Not what you want, not what you wish for, not what you're hoping to achieve, not what you enforce with KPIs, but the identity of the team when nobody's watching. That's what you're getting. That's the level of quality you're getting. And if the team doesn't want to write tests, they won't write tests. If you're reinforcing the metric will be gained. So the only way forward is for you to understand that, yes, our team does not ship this kind of code. We're not punishing them for having shipped it but not tested it. We just said we're never shipping this kind of code. Right? Like the process makes it impossible to ship untested code. That would be like that would be not process reinforcement. Because then it's non-negotiable. Then it's like, yeah, of course, we need to write tests. Everybody in the business understands this. Everybody in the business supports this. And those who struggle due to lack of experience or knowledge can learn. And the teams and the leaders and coaches and staff engineers are there to provide platforms and services and trainings and internal tech talks to make sure everybody, basically gets onboarded onto the process that is there to maintain a high level of quality or security, privacy, etc. And ultimately, it comes down to the identity of the team. Do they identify, when they start doing TDD, do they identify as a team that takes quality very seriously and they want to refactor and they refactor and they respond to the needs of refactoring? They don't complain about it. They don't say, refactoring, that never gets approved. Versus, no, like what can we, refactoring doesn't need approval. We should be asking ourselves, well, what are we working on today? Okay, what needs refactoring? What are the things that need refactoring can we refactor today? Right, so it's remaining in this optimistic, like forest mentality of, we have a day. Yes, we need refactoring. We all agree. Cool. What can we refactor so it's economical? And then we can implement the feature. And maybe it's too much, maybe it's too little, but we will learn something. If you defer these decisions into the future of, no, that needs to be approved, that's not feature work, that's complicated and slow, and that needs to go higher up, that's an identity problem. It's not a process problem.
I actually need to go. I want to say thank you for the session. It was very insightful for me to understand what self-testing code actually means, and that it's not too new for me. But yeah, thanks for the explaining, Dennis. See you next week to the reaction, I think. We have next week a reaction, isn't it?
Yeah, I need to talk to you regarding another guest for TDD. I just remembered.
But
and yes, we're doing...
Because I actually really need to hop off right now.
Yeah, I will close.
See you. Maybe you have some time left. You can continue this.
I will.
No problem.
Yeah.
Okay, see you everyone. See you next week. Bye-bye.
Ciao, Adrian. So just to wrap up, doing live streams, like impromptu live streams on Substack now during TDD February, just testing out the technology. I realized that people are a little bit more chatty. I don't know what it is. Maybe it's the phone. Maybe it's the way LinkedIn presents the whole stage and YouTube. But every time I had a LinkedIn live, there was a lot more, let's say, live conversation. This feels more like a webinar, and that feels more like we're going live. It feels more like a stream, like a live event where people come up and talk. Sometimes we've managed to replicate that experience here on LinkedIn and YouTube and Twitch, but I would say it's more the exception than the norm. So I'm experimenting with lives. It's not OTJ related. It's just me in the context of TDD February. We had a live today. We had a live yesterday. I'm posting some clips, and I will cross post them to LinkedIn. So if you're not into, if you don't want to satiate the dopamine frenzy of following me on 7 different platforms, then you can just follow me on LinkedIn, and I will make sure you get the relevant clips. There's that. The other part is, why are we talking about this? We're talking about this because when I see there is this sort of moralistic bargaining going on LinkedIn and social media, and especially Twitter, about TDD and what TDD is, and it's sort of focused on like the steps and the mechanics of it, and some people say it's a waste of time, and for a lot of people it is a waste of time, right? And we never really get down to the really important stuff. But no, it's not about writing tests. It's not, because I always, in trainings, I started discussing TDD from the context of design. From, the design of the code is much better. It's much more modular. And in reality, that's a waste of time. Because, yeah, sure, but it still needs, like, a good developer will design better with TDD. But for a bad developer, an average developer, the lines get very blurry. I'm not saying it's worse or not better. It just, I don't have solid data on it. What I do have solid data on is that TDD is about this idea that if we are integrating continuously, then I want to refactor frequently. And I won't refactor if I don't have test coverage on what I just created, right? So there is this sort of demand delay of, damn it, we need to refactor something. I need to test cover it first. And then the test coverage, the sort of ad hoc test coverage after the fact becomes another thing. You reject the estimate and the ticket, you create a subtask, you say, I need to refactor something in order to test it, and then we can continue to work on that. And it just feels so artificial. And then you keep creating like all these like little barriers and blockages in like the actual flow of work that makes it very difficult for other team members to integrate with that. So the whole idea with TDD is not so much that there are those mechanics of those 5 steps, but instead that this is a loop, and we want this loop to be running as tight as possible because there are other loops going on, right? So we don't want to maximize the, this sort of lone wolf mentality of, I want the engineer to be locked in and focusing on just coding. No, I want the team to be locked in on the product. And for 99% of the work, the types of work that is 99% of the time mostly UI facing or bookkeeping or data driven, I want the team to optimize for the flow of the team, not for their own individual flow. Which means we want to maximize the amount of iterations we can do whenever we're touching code. Because whenever somebody's touching code, they can get derailed and like go down a rabbit hole, right? So if the coding becomes the focus, then you need interruptions. Get the team together and have a product meeting, right? So it's a matter of priorities, right? So either you're optimizing for product engineering flow, you will need to interrupt engineering. If you're optimizing for individual flow, you will need to interrupt them for, sorry, I phrased that weirdly. If you're optimizing for individual flow, then you will need to interrupt that flow with interruptions of product meetings. If you're optimizing for product flow, you will need to interrupt that product flow, those like pairings and ensemblings and mobs, with sessions of programming. And TDD is meant for this context. TDD is meant for a context where there's a designer, an engineer, a backend engineer, a front-end engineer, an app designer, a UX designer, I don't know, like pick 3. And they're building a feature and they're not quite sure what the right way of building it is. And they're iterating very rapidly. And they're staying together in flow as a team. And every time somebody has to go, you know what, I need to focus on this, I'll be right back. To make sure that I need to focus on this, I'll be right back, that is as short as possible. That it is very clear what they've just did. And when they come back, they get immediate feedback. And if the feedback says, oh, that's great, but we're a bit off on the design or we're a bit off on this detail, that they can go immediately back and fix it and then deploy. That's the idea. right? The idea is on this constant collaboration with your team to get feedback, and if there's no objections, we're gonna deploy, right? So it is optimizing for the entire value stream of the organizational units of the department, of the team, of the I don't know what else, the squad or the task force, let's say, if this is some kind of incident response, to optimize for the overall velocity of the ship, not of the crew, because there are diminishing returns to breaking up work in such a way that every engineer individually can be, you have 8 hours in a business day, so we want you to be coding 6.5 hours, and we will break up work in such a way that you can work uninterrupted without communication, without meetings, and you can just focus, and then we have the daily scrum, and then we have the stand up and blah 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 blah, and then you go to lunch together. And the diminishing returns comes from this idea that the demand of the stakeholders does not match, like, the shape of that demand, like how it is explained. I say I want a feature, and you immediately think, well, one person can't do that alone. That'll take 2 teams a month. That 2 teams a month has a certain shape. That means 2 teams need to be sitting together for a month and working together constantly. If you break up that work so that it can be planned individually and compartmentalized individually, then the output that organization produces will be of an incompatible shape to the stakeholder. Like, there will be like so minute details and small deliverables that then somebody has to orchestrate those deliverables back into a sensible whole. You've probably seen this, where you might be testing something or you write a test, and it just is like a really weird slice that doesn't really reach end to end, and you just created a new backend feature that the user has no idea how to use or how to interface with, because it required 7 people to get the full integration. It might require a security audit, a database change, front-end change, a re-release of the iPhone app, backend change, the versioning of the backend, some change in load balancer configuration. It might involve 6 people. The point is to get that across so that nobody gets distracted, so that everybody who's there says, okay, it'll take 6 of us, and 3 of us will stick with it from start to end, rather than it being a baton and you just keep passing the baton to the next person. At the moment, it's more than 2 steps away, you lose track, right? And then it becomes the problem of whoever is currently carrying the baton. The problem is that has a single point of failure. If that person gets sick, now this work gets stuck. And then if you're optimizing for the chance of work getting stuck, you start parallelizing it more, which means now there's more batons. And now you create this factory effect, and that's how you create feature factories. Engineers lose track of like what's going out, when is it going out, what feature branch is it on, when is it getting merged, when is it being rolled out. If it is being rolled out, is it being publicly released? If it is being publicly released, which clients are using the feature? On what time of day are they using the feature? Why are they using the feature? How do they benefit from the feature? What features are not being used so I can remove them? How do we know that? What guarantees are we communicating? Does the landing pages use any recordings of demos of user interfaces that we removed? Right, so it becomes this like very complicated, like many small moving parts that are not really cohesively working in tandem. So the point is, TDD is a workflow where you're emphasizing we will work together as a team and we will make mistakes. So we want to correct those mistakes as we find them, because it's clumsy to document the mistake, right? So it is easier to be honest about that this is an experiment. I don't know if this feature will work. So I will add a little bit of extra like investment upfront to make sure that I can immediately react on the most obvious hooplas as I receive more knowledge, rather than it becoming this sort of deferred, this was, there's a bug. The bug was an expression of our process dysfunction, and we will document it. We will document that, that there's a bug. We couldn't have predicted it. It's hard to refactor. It requires focus. But it should be done by the author, because nobody else understands the code. And the author is busy right now with a different feature, because by the time they were free to fix it, we didn't know about the bug. at the point when we learned about the bug, they were busy. Right? So that is what you're optimizing to prevent. So this is a purely risk management strategy. It is a strategy meant to have self-testing code at the contact points that would demand the most opportunity for refactoring, and then you act on it rather than having to plan it, talk about it, have a meeting. All of these processes, continuous integration, continuous delivery, pairing, test-driven development, these are all stemming from extreme programming principles and values, where the core idea is that it's very easy to contact the customer and ask them for feedback. The customer being the person, the customer is the person who pays for the software, who invests into the software. The customer isn't necessarily the person who benefits from the software. That's a terminology thing in extreme programming. But it's this idea that, the team can talk to them, the customer makes key prioritization decisions, and the customer decides what's being worked on next. And the engineering team, they have full autonomy to make that thing a reality, to make that priority a reality. Which means that the moment they start working on it, there's no meetings. They just work together on it. There's no, oh, I blocked on this. Oh, okay, we'll do it tomorrow. We need a meeting. Let's work on something else. Right? Because then you have priorities 1, 2, 3, 4, 5, and you do a little bit on one. It's like, oh, I did as much as I could. Let's do 2 now. Oh, I did as much as I could. Let's do 3 now. Oh, I did as much as I could. Let's do 4 now. And then you keep handing it off to the next person. And then they go through a similar cycle. And then what inevitably you find is that you get this Kanban problem of your VIP limit is the number of people in the process. And then you have 7 people on a team, 7 things in progress in 7 different columns. And then people see, oh, 7 times 7, it's 49 cells. So we should probably have 49 things in the board to make, so it makes sense. And then that's what you gravitate towards in Jira or Trello or whatever you're using, because there is way too much compartmentalization going on the work, because the feedback was not acted upon when it arrived, because naively everybody thought that they got it right the first time, which Kalayan already said, doing it perfectly the first time, there's no such thing. Yeah, I just want to emphasize that the idea of self-testing code, TDD isn't the only way to get there. You can do TDD with hexagonal architecture. You can do functional decomposition in a language like Erlang. You can do event sourcing with event modeling. These are very good alternatives that I have checked, and it makes sense. The studies are still being done on them, right? We don't have a lot of data on TDD and the alternatives, sadly. Well, what I can say is that if your alternative is, I will just kind of wing it and implement it, then hand it off to QA, then any of these processes are going to be an improvement. But that doesn't mean that you need to do TDD if you don't want to do TDD. You can get the same benefits of this process, of this kind of thinking, with any of the other 3 that I mentioned. But I find TDD to be the simplest to explain and engage into, and it is the least disruptive of the processes. As much as that is, going from any language to a functional language is going to be a huge disruption, unless you're on a functional company. Going from any process to event modeling and event sourcing is going to be a huge disruption if you're used to CRUD sourcing, state sourcing. Going from a typical object-oriented system that is a little bit more leaner and going towards hexagonal architecture with TDD is going to be a huge disruption unless your whole enterprise is on board, right? So to me, doing TDD with a small task force or squad, that seems of all the alternatives, if this is what you want, seems to be the best, easiest, most sort of available alternative. Yeah, that's it for today. Thanks for being with us. I will have a live tomorrow to highlight the relaunch of the booklet. It's a bit sexier. I changed the layout a bit. There's no more weird fonts, no more weird emojis. I removed some content that didn't make sense. I added some new content that I mentioned today. And it's a nice little booklet that has these ideas that I mentioned today in a summarized form with some examples for leaders. Plus, you can share it with your teams, sort of, to hype them up for this kind of thinking, for this kind of working. Still, as always, there aren't any code examples in the booklet. You can find it on my, it's highlighted on my LinkedIn page in case you're wondering. But that's not the point of today's episode. There's no code examples in there because I assume you know how to code. I assume you know how to Google TDD and read it, and like to read the initial steps. So that's not the point. The point is that mindset shift of like, where am I on taking quality seriously? Where am I on my non-negotiables? Like, is testing something that is non-negotiable for me? And how do I justify it in terms of the business strategy? How do I justify it in terms of business output? That's what this book is really about. So that said, thank you for being with us today. It's lovely to be on a regular cadence once more. TDD February is going to be a lot of fun. The Nick Shumeko episode will be on February 26th. Same time, same slot. It's probably going to be a 3-hour episode. Judging from last year's experience, there's going to be like hundreds of people here live. It's going to be one of the busiest. I mean, last year it was the busiest stream in the entire year. So it's coming soon. It's going to be exciting. Have a good evening. Have a good night. And I'll see you all tomorrow if you'll join me for the Substack Live. Thank you. Ciao.